Hi, I'm Patty Howell. I'm doing a presentation today about Georgia's energy profile. I work with the Artesian Alliance, which is Thronatisca Heritage Center, Flint River Aquarium, Cheehaw Park and Zoo. What I'm hoping that you'll get out of this today are some tools for teaching about energy in Georgia, no matter whether you're in the middle school or the high school. I hope to help you to solicit student ideas, what they think about energy, where it comes from, and especially be able to use some local data so that you're not just throwing numbers out of a textbook. I hope that you can give them numbers that mean something to them because it's from their own state. And I also want to share some teaching tools that I use that hopefully you will be able to apply whenever you're doing this or other things in your classroom. So the first thing that I have for you, and I do this with my students, I have a survey. Where does your energy come from? And this is easily collected through a Google quiz. So it's very interesting to have them, give their ideas. Where does energy come from? So I'm trying to show you that quiz. And it is not wanting to open up for me just yet. So this Google quiz is just very simple. What percentage of your energy usage, your electricity that comes into your home is generated from oil, coal, natural gas, and renewables, nuclear. And it's just a probe. And I'm not really surprised anymore, but generally what my students think is that they're getting about 40% from renewables, and that very little is coming from nuclear. And so it's interesting to see. And they also think a lot comes from oil. So it's very interesting to see what their thoughts are. So I don't think that I would be able to teach energy usage without having some kind of an idea what they think their energy comes from. So it's pretty interesting to see what they think. It also generates some discussion. Of course, energy is a very political issue, and it's something that they really need to know. I teach juniors, seniors. They're getting ready to start voting, and so it's important for them in terms of making political decisions. But even if they're in middle school, they need to understand where their energy comes from. Now, the next thing that is pretty important is getting an understanding of what their misconceptions are. Research shows us that there are so many misconceptions when it comes to energy and electricity. First of all, energy is very vague. A lot of people really don't even understand what energy is. And then there's also a very big difference between energy and electricity. So some of the big misconceptions, if you are teaching about energy, is, and there's many papers written on this, but some I thought that might be more pertinent to what we were doing here today. A lot of people think that energy is a force, and it's not a force. So they don't really understand the difference between forces and energy, even though there's a relationship there. Energy is not actually a force. A lot of them think that energy can be recycled. And then they also get kinetic energy mixed up with momentum. So if you're in a physics classroom or physical science classroom for high school, that would be something important, that a misconception that you'd want to pay attention to. Also, we are guilty of misusing lexicon or language all the time when we're in teaching, when we're just talking normally to students. Television shows, news, everything. really messes with these students' mind, because we talk about loss and gain of energy, and students really get confused about energy being lost. Well, as teachers, we're telling students that energy is neither created nor destroyed, but yet if you watch a video about energy usage, they talk about energy lost through transportation, through power lines, and so on and so forth. So this is something that you might want to clear up with your students and start using common lexicon, and letting them know, especially if they're in high school, that even though energy cannot be created or destroyed, that it's always transformed. We do, in normal language, talk about loss of energy as energy that is not usable, because as it's running through power lines, there's resistance in the power lines and things like this. So, addressing and using lexicon consistently is important. Our electric bill, this is a big thing that's difficult for them to handle, because our electric bill is measured in watts. And so that is not energy, that is power. And so really, we should be saying our power bill and use of power in our home, because the unit for energy is joules, but the unit of power is watts. And so the electric bill causes some confusion. Conservation and saving, when we conserve energy, energy is conserved mathematically, especially if you're teaching a physics class and you're talking about conservation laws. But saving energy is a little bit of a different concept. And so understanding, that when we talk about conservation laws, that we misuse conserving energy in normal language to mean that we're just we're saving energy a little bit. So, when we're teaching it, just need to make sure that we address our lexicon and tell students that we kind of talk in science one way, but sometimes those terms are used differently on the outside of the classroom. Now, data. This is the big source, and what we need to do for three-dimensional teaching. Students really need to get into data, and it needs to be something that's important to them, because whenever we look at these problems that are on our end of course test, they're just out there. We really don't have any connection to them. But if we can understand what Georgia's energy profile is, and it really is something that we can, connect with a little bit better. So I use this EIA, which is the U.S. Energy Information Administration, extensively. And there are so many things that you can do with this. Now, one of the things that I've got all kinds of different forms of administering this or using this, and one of them is a Flippity game. So if you're familiar with Flippity, they can do a scavenger hunt with this website. And so well, all right. So with this website, you can see all kinds of data about the energy usage in Georgia. We can see where we rank per capita. And this is a great feature that I love, is this interactive map. You can look at the different layers and mark the county boundaries, so students can go in, look at their particular county, zoom in and see what facilities are in their particular county, they can put their address in and see exactly what's at their address. So if there's and these are the little codes, so you can see the different types of power plants, whether you have solar power in your area. And so that's pretty interesting. The way that I would use this in a classroom, I've got about 3 or 4 different ways on here. And one of the ways that I would do this, I would use a Flippity scavenger hunt. And so you click on the icon and it says Georgia is a leader of something exporter. So I would go here to the website, and under the energy profile, you can see that Georgia is a leader in wood pellet exporting. And so I would go through here and type wood pellet. I would unlock that key. And so I have several different pieces of information that they can find the data, the answers from this page. And as you'll notice, this is the biggest place where we get our energy is from natural gas here in Georgia. The second is nuclear. Coal is the third. Renewables is fourth. And then we still get a little bit of hydroelectric energy from Georgia. So I've got a lot of, that's one way that I would use this in my classroom to have students dig into the data. And another way that I would use this in my classroom, just after we've done this one time and presented the information, I would probably do a little quick bell ringer with 2 or 3 questions that is just sort of a refresher for them. So the third highest source of energy for electricity production in Georgia, and that is going to give a little picture, and this is through word wall. And so I'm thinking that it's going to be coal. So click on it. And that students can answer that assesses sort of in a fun way if they remember information from that website. So the second highest source of energy, and if they remember, they're eventually going to get a picture, but we should be seeing a little uranium pellet here. It's pretty interesting for them to see that that's the size of a uranium pellet. So I'm going to go ahead and close that out. That's just one method that I would use to get them engaged in that website. And another method that I would use to engage them in that website is just a scavenger hunt or a Google form. And so the Energy in Georgia web quest, so which provides the highest amount of electricity for Georgia, the second highest, using the map feature, what is located in your county, how does Georgia rank in carbon dioxide emissions. So again, this is the website that I would use. It's full of all kinds of information. And then as far as engaging the students in that information, I would use those tools. Now, if you have, you would be teaching this information in either chemistry, biology, physical sciences, physics. So it's important that we tie it in with whatever class that we're teaching. So if we are teaching this in biology, I might really want to, focus on biomass. And so, do we have any, if I'm talking about the, what is biomass, I might want to actually go here and see, where is the, nearest biomass facility to me. And I can click on that. If I'm in Albany, there's MCLB, landfill gas to energy. And they've got a 1.9 megawatt capacity. Biomass is their primary fuel. So it's just interesting to see, if you're talking in biology about biomass, that yes, there are places right here where we live that use it. If you're talking about physics, you're going to hit, and also in physical science, you're going to hit that standard for nuclear energy. A lot of people don't realize the importance of nuclear energy here in Georgia. So we have nuclear energy plants, and there's actually 2 more that's coming online in Georgia. So you can read right here that we have 2 new nuclear reactors under construction at Plant Vogtle. So it's pretty exciting to see. Then if you are in chemistry, you probably are going to want to talk about the combustion equation and some stoichiometry. And right here's a pretty important number, the carbon dioxide emissions for Georgia. We rank 11th. And if we want to see a little bit more about the carbon dioxide emissions, we can do the combustion equation and see we emit in million metric tons, 132 million electric tons here in Georgia in carbon dioxide. So you can do stoichiometry with real data instead of just making it up if you're in chemistry. So moving on to some other great energy resources for you and some activities that you can use in your classroom. Energy density. A lot of people really don't understand that concept of energy density and why we use some energy sources over others. And so this is energy education from California, I think. And it is a great explanation and comparison of energy density. So if and we want to take as much of the teaching out of it and put as much learning into it as possible. So one way that I would integrate this into my classroom, instead of me just sitting here, telling about it, reading it to them, I would probably incorporate, if I were doing it hands-on in class, this is a great scaling activity. So if you have pony beads or adding machine paper, that long paper, I would have them, scale the different types of energy density. So, like 19 pony beads is in a kilogram of sugar, the megajoules in a kilogram of sugar compared to 46 pony beads for gasoline. And then uranium, you probably wouldn't have enough pony beads to do that one. But maybe they could do a weight conversion if you're in a higher level math class. Now, if we need to integrate some online tools in our virtual environment. So what I would probably do to integrate this, I would probably use another Flippity activity to assess whether or not they are understanding it. So let me pause this while I find that Flippity activity. All right, so one way that I would probably assess whether or not they're understanding and actually reading the article is I could use a Flippity game. So this is a matching game. And it speaks to them, so that is kind of neat. And you just, how far would your gas get? Anyway, y'all get the hang of this. and I'm not hitting on any right now, but that's one way that I would integrate this into where I wasn't just talking about it. But it's a very interesting, because a lot of people just really don't understand that concept of energy density. So I would want to, so I always make sure that my students are seeing, you know, how far, if we were to only use wood, this is pretty interesting. How far could you go if you're, you know, if you only use wood in your gas tank, or if you're using coal? And then also talking about what are the advantages and disadvantages. So some really good opportunities here to integrate scaling, and you know, also just understanding in terms of nuclear power just how much more energy dense it is. So another great resource that brings in data from Georgia to our students is the Georgia Power website. And what you have to do, you have to go to their site map for this. So it doesn't come up automatically, but I've included the link here. And with this, there's all kinds of information on energy sources, so they can you know, actually learn about, you know, what Georgia Power is doing. And a lot of them use Georgia Power for their energy company. But what I really, you know, they've got some great information here. And also, I would want them to, one thing we always have to tell our students too, this is steam coming out of here. This isn't some crazy poisonous chemical, but it's just steam. So that's one thing that we definitely want to make sure that they're understanding. But when they're learning about and doing this stuff through websites that they're familiar with and that, you know, they actually use, then we're just building that connection with them. So what I really love is going to the solar program information, and we can really integrate data through the community solar program, and it explains it. There's also a great website where let's see, some of the behind the meter programs, the PWatts calculator, which can be found on this website from Georgia Power. And what is really great about this is we can talk about solar energy. This is the ultimate source of energy for everything. So whether you're talking about the energy in biology, the sun is the major, you know, the ultimate source of energy, or whether you're talking about physical science, this is important that they understand. And it's really cool that they can put their address in so that they can actually see, this is my address that's in right now. They can actually see if I were to install solar panels, what I would get from my solar panels. So it tells me, we get this system losses. So the energy companies do use that term losses. So we can look at loss calculator, and we can see some of the reasons that solar energy isn't going to be 100% efficient at my house. And so I think this is really cool. 3% is going to be lost due to shading. Light induced degradation, 1.5%. Wiring is a 2%. And in physics and physical science, we talk about the resistance in wiring. And so this really makes a big difference. So in terms of, you know, energy at my house, 2% is, you know, kind of a big deal. But if I, you know, install solar power, I can see I'm not going to lose any due to snow, but how would that affect me if I lived up in North Georgia? So, you know, it's a pretty good connection whenever you can actually use your own home for this. They can draw their solar system. So if I go back here, you can click on each corner of your house, and you can customize, draw your own solar system. And I have lost my house in here somehow, but that's one thing that they can do, and they can click on their house and you know, where would they place their solar panels to get the most out of them. Okay, and so and I actually do have I did get solar panels, so this isn't completely updated, or else it would show my solar panels. At any rate, then they can go to this next page by clicking on that little arrow and showing me my solar radiation in my home or at your school, wherever you like, in terms of months. So especially if you're working on graphing, and this is a great graphing, you know, set of graphing data, because it comes right from their house and it ties right in with the standards. It's also, you know, 21st century skill for them, being able to, you know, and a great life skill. How much, you know, what value annually would that solar panel, would one solar panel give me, or however I design my solar panels. Then another great resource to use in the classroom is this book, Energy for Future Presidents, by Richard Muller. And I recommend this just as a teacher. It's a really great read if you're kind of corny like I am, but and it helps to clear up some misconceptions that I had, and gives me some starting points. And what I will do with this, I have little pieces, and I'll assign, you know, different maybe paragraphs at a time for them to read, maybe as an opener or maybe as a homework type of assignment. And another thing that I would do to really bring this home and to really integrate my data is bring up some argument-driven inquiry that are, you know, right here locally. So one thing that you might assign your students to do, and you could do this at any grade level, but gopher tortoises, will they or will they not be harmed by increasing the percentage of solar power generation? So right now in our political climate is to increase the amount of renewable energy. Right now, renewable energy is not that high in Georgia. So if we are going to increase it, we have to understand that it does have impacts on the environment and the habitats around it. So on one hand, we would not be producing so much carbon dioxide, but if we convert so many of our longleaf pine ecosystems into solar power panels, how will that affect our habitats for gopher tortoises and the other things that depend on that? So that's, you know, one way that we could implement argument-driven inquiry, and they could use data to argue, you know, both ways. Another thing, Gulf sturgeon, will it benefit from the increasing hydroelectricity in Georgia? Now, a lot of students really don't understand that hydroelectricity is pretty bad for marine, or not marine, well, for our freshwater ecosystems. They see that dams are great because you got all this falling water and they create these reservoirs that we can have great fun boating in, but they don't understand what it does to the, the different species that live in that area. So this is a great opportunity that you could use in biology, middle school, high school, physical science, just understanding, doing temperature comparisons at different, different dams and getting the data from that. So there's lots of opportunities to integrate local data so that we're not just using the, things from the textbook, and so that students can understand about electricity impacts that it has on their lives and actually using their home, their schools to bring it closer to them. There's also plenty of opportunities to integrate the tools like the Flippity, Google Forms, WordWall, making games out of it. And one of the things that I would also do with the argument-driven inquiry, I would use the, an online platform where they could do their recording, and I've forgotten the name of it, but make their arguments online so that they could publish something for people to see. So if you have any questions, comments, if I can help you in any way at all, please email me. I'm happy to help you, and I hope that you will come to Chehaw or the River Aquarium or Thornatiska so that we can, give you some opportunities with some hands-on field trip fun.